In this video, we'll introduce the base model used in the wind farm application example. Study case base case should be activated. Here, you can see the network model. The network consists of 6 individual wind turbines, each supplying the 20 kV network via a step-up transformer. At the point of common coupling, or PCC, there's an external network. And at the wind farm's substation, a capacitor bank is connected. Let's take a closer look at the wind farm substation. At the top of the diagram, the PCC is shown, which is part of the distribution network. The separation between the distribution network and the wind farm is indicated by the property line. Here, the 4 switch bays of the wind farm substation can be seen, as well as the location of the 2 cable overcurrent protection devices and the voltage protection device. Let's go back to the overview diagram and look at the wind turbines in more detail. The wind turbines are all identical. They have a rated apparent power of 2.778 MVA and a rated power factor of 0.9. A dynamic model has already been assigned to each of the wind turbines. On the load flow page, you can see that the active power output is to be defined according to wind speed using this wind power curve. The wind generators are all controlled by a single station controller which controls the reactive power output. On the operational limits page, you can see that a capability curve has been applied to the wind turbine model. The station controller can also be accessed here. On the load flow page, we see that the control mode is set to power factor control, and the point in the network at which the power factor is controlled is shown here. The station controller applies a cos phi as a function of P characteristic. When the active power at the controlled node is 7.5 megawatts or less, the overexcited power factor is set to 1. When the active power at the controlled node is 15 megawatts or more, the underexcited power factor is set to 0.95. Between these active power set points, the power factor decreases linearly. In the table on the Distribution tab, you can see the wind turbine generators and the proportion of the total reactive power that each is supposed to supply. Let's now run a load flow. The results are summarized here. We can see that the total output of the generators is 15 megawatts, with each generator contributing equally. With some losses in the network, the active power from the wind farm as a whole is a little less than 15 megawatts. Cos phi is controlled to 0.953, and the resulting reactive power being absorbed is 4.64 megavars. In order to investigate the reactive power control further, let's add another wind turbine to the wind farm. We can add a terminal halfway along this line to make the connection. The new wind turbine can be created using a template that's stored in the project. Let's look at the attributes of the new generator. A dynamic model has been assigned by the template. And on the load flow page, we see that the generator has been given an active power set point of 2.5 megawatts and a reactive power set point of 0 megavars. A megavar capability curve has also been assigned. If we now run another load flow on the system, we can see the active and reactive power outputs of the generators. You can see that the new wind turbine is generating 2.5 megawatts, but although the other generators are all contributing underexcited megavars, the new generator is producing 0 megavars. This is because the new turbine is still configured to local control. In order to let the new turbine participate in the reactive power control of the wind farm, we need to add it to the station controller. Let's run the load flow again. Now, at the point of common coupling, around 17 megawatts of active power is being fed into the grid. Cos phi is controlled to 0.95 according to the characteristics that we set in the wind farm controller. The new generator is now operating at the same megavar level as the other generators. But there's one more thing that we should do. The cos phi p characteristic should be adjusted to take account of the extended active power range, because now the wind farm can generate up to 17.5 megawatts. The controller is now correctly configured for the additional generation.